Hey everyone, this is for UPHYS 2 Lab 5 Spring 2020. We are a lab group with Victoria Guarnaccia, Robert Jones, and Emily Sigmund. This is the take-home project-y thing, and our group decided to make a mobile. This is it, fully functional, in equilibrium and rotating. And I'm gonna hand it off to Emily to explain some of what we did.
Yeah, so we chose to make a mobile because we thought that it would be relatively easy to calculate what mass was needed and where we needed to place it in order to put the system back into equilibrium. It started out as the broom rod, which is that black rod, and a free hanging mass of a stapler. And then we created two more smaller systems within it using a pen and a pencil, and then the salt, pepper, and salt shaker, and the chess piece and a pocket knife on the other side to put it back into equilibrium.
Basically, in order to calculate where we needed to tie the string on each of the rods themselves, we had to calculate the mass. We had to find the mass of each object and then find the center of mass. So we started with the pencil side, found both the masses of the objects, those two salt and pepper shakers, found the center of mass between the two, tied the string there, and tied that to the rod. We did the same thing on the pen side with the knife and the king chess piece. And then finally, we added both of those masses, both masses of those two systems together, along with the mass of the stapler and the distance it was apart from they were apart from each other in order to find the center of mass of the rod to hang it up. Back to you, V.
Yeah, I would say that it worked pretty well. These smaller systems won't stay completely in equilibrium, but that's probably error in the masses that we weighed, as well as just some general error. The scale we used is not particularly accurate. It is not digital. It is something that we had to eyeball to find the masses. So that could be one reason, but all in all, I would say this was a pretty successful experiment for a take-home one. Anyone else have any final comments?
Yeah, the pencils and pens are also not completely uniform all the way across, because the pencil has one end that's like completely wood, and then one end that has an eraser and a piece of metal on it, as well as in pens, where the ink is and where the nib is at one end, so it would be a little bit heavier on one side than the other. So since it's not uniform all the way across, that could also cause error.
And same with this broomstick. It is quite literally a broken broomstick. So it's also not the most uniform of, moment arms. Well, cool. This was our experiment. Yeah, that's it. Have a good one.